Thank you very much. Hey, thank you very much for everybody for joining. This is about the panel discussion for the how distributed and edge cloud affect the suppliers' edge cloud solutions and products. And over here, over here we are going to discuss about the edge cloud data center needs to meet strict requirements both from the telco world and IT workloads. And over here, that kind of good example of that kind of pretty hard requirements on the telco world is 5G virtual radio access network. And especially over there, when we talk about this baseband real-time part, this virtual distributed unit, because it has like a specific requirements for the hardware from the layer 1 software acceleration point of view. Then on the IT workloads, you know that there's like this artificial intelligence and machine learning is like coming like really strong there, and there are like specific use cases. So that is bringing like a new use cases on the enterprise area. And over here, we are going to discuss now that all the like partner companies over here in this panel discussion, they have already like their solutions and how they need to take into account when their solution needs to meet also like these requirements. And our panelists, we have Sven Freudenfeld from Lanner. Then we have Kai Lee from UFI Space, Stephen Wang from Vivint, and Mike Moore from Nokia. And my name is Mark Hockren. I work as a moderator. And over here, so we are going to have a discussion first between panelists, and then you have like opportunity to send the questions after this panel discussion. And now when we start that actual like this panel discussion, so as a, like a starting point for each panelist, there's like 2 questions that we would like to hear your feedback. The first question is, how have you taken into account new edge cloud deployment requirements in your product and solution? And the second question is, how new use cases in the edge cloud affect your product and solution? And over here, specifically on this enterprise AI and ML use cases, and then this 5G vRAN as an example. So Sven, could you start? Thank you.
Yeah, sure. So we are an active member. Well, we are a participating member of OCP, and you know the background of Lana for the people who don't know Lana in details. But traditionally, we came from the ODM space, right? So we building appliances primarily for enterprise cybersecurity and networking. So it's a network computing company in its core and its DNA. We started looking at the telco market about 4 years ago when I joined Lana initially. So we have evolved the whole concept of disaggregation, starting on the enterprise, so SD-WAN, universal CPEs, which is really ticking off. We see an increase on that conceptual model for the last 2 years, and now with COVID-19, we see even more ramp up on that. And where we're focusing on now is the next level, and we have engagements with service providers who are identifying the next solution for disaggregated networks. And the first thing in mind coming at the current stage is the DU and the CU option for Open RAN. So these are elements where we believe that a disaggregated networking infrastructure will be the strategy for most of the service providers coming in 21 and 22. So we have been focusing on that, and then also, of course, we have created a white box for the last couple of years, which was based on a concept traditionally on some legacy architecture, which called ATCA, Advanced Communication Telecom Architecture. So we did a different spin on that, which became a sort of a modular white box appliance with scalable compute networking as a part of an infrastructure. We built in programmable networking, meaning we eliminate the need of a top-of-rack switch, either Barefoot to Fino or Broadcom, what have you. So we integrated that. So our idea is that, you know, most of the service providers the challenges with truck roll for deploying these solutions are the biggest cost burden. And now with COVID-19, everybody is moving towards an SDN approach, software-defined networking. And that requires some integration of networking, computing, acceleration encapsulated into the platform, so completely integrated. So we have adopted the open edge concept, but slightly a different way. We're fitting it in the same envelope. The other key element what we're integrating into this is the need for provision time protocol, so meaning IEEE 1588 at the DU site, not at the disaggregated cell site, but at the DU site. So these are some of the elements that we have been considering on this.
Thank you, Sven. Let's continue then. Do we have a Kai already in the call?
Yes, this is Kai. Good morning, everyone. Yes,
hey,
and
maybe you could give like your view for these two questions.
Okay, sure, no problem. Thank you. Yes, my name is Kai. I'm the technical director for UFI Space, headquartered in Taiwan, and I personally work in San Jose, California. Just a really quick overview on what we do and how we fit into the specific topic that we are talking about today. Our company focuses in the end-to-end telco architecture, from the RAN all the way into the central offices. And then we have developed end-to-end solution, including in the front hall, in the mid hall, and also the back hall, and then all the way into the central offices. With respect to the edge computing conversation that we have today, the devices, the white box devices that we build is incorporate into, in conjunction with some of the ecosystem partner that basically they are in the what we call the MEC, the mobile edge compute area. And then as we develop our equipment, let's say at the front hall in the WAN, like our cell site gateway, we have incorporate the solution so that we can inject edge compute opportunity so that we can analyze traffic as they go from the cell tower, let's say into the cell site gateway. And then after they starting to go into the back hall, we are the aggregation equipment and also the back hall equipment or the central office equipment. We are also applying the same design concept that we also can have edge equipment, edge compute equipment that we can inject for analytic type of analysis. So in a nutshell, from end to end, from the front hall all the way to the central office, every piece of the equipment white box that we build, we have the mindset that we can partner with the mobile compute edge equipment ecosystem partner, that they can easily add there into our solution so we can fit into this overall edge compute component. So that's kind of, the overall architecture of the equipment that we build and how we partner with the ecosystem from the edge computing. And then the whole concept, let me talk a little bit about the whole concept of doing all this, and this might have covered by another panelist speaker. Because we focus with quite a lot of different telco carrier, which they have thousands or even tens of thousands of cell sites that aggregate through our cell site gateway equipment into the backhaul, eventually to the central office. So if you think about this, it's a very large scale with a lot of information that need to be analyzed. If we allow all those things to come all the way into the central office to do the analytic, that will have, number one, a lot of overhead, and number two, burning a lot of bandwidth for things that might or might not be relevant. I want to share some statistic with you. We do work with a very large carrier in North America that has tens and thousands of cell tower utilizing our equipment. And then one thing we learned is, turns out some of these cell tower traffic coming in, in average, if you look at them, they may be operating at about 30% utilization. So that means there's still a lot of idle space. If we send all this trending and all these traffic information all the way to the CL without having edge computing to do the analytic, that actually will cause a lot of unnecessary processing and unnecessary bandwidth to send those information that might not be relevant. So that's the whole idea why when we build our equipment, we are injecting our edge compute point of access into the front hall, the mid hall, and to the back hall. And rather than just in one places, we actually trying to do the architecture in multiple places so we can collect the different type of trending and different type of traffic pattern, things in that nature. So that's kind of, our whole design concept without getting into the specific boxes that we build. So I'll stop here if anybody has any questions or comment. Okay, thank you.
Thank you very much. And let's continue then. Stephen, are you in a call?
Yeah, hi, good morning, everybody. This is Stephen. I'm from WeWin. I'm based in San Jose, covering the whole America. So regarding to the two questions, I think in this panel discussion, the first one is that how have we taken into account for the new edge cloud deployment requirements into our product and solutions? And as you know, we are a cloud infrastructure designer and a manufacturer. And if you look back how the traditional infrastructure was made, basically design started with multiple platforms, for example, like x86 or ARM, and then start from motherboard design. We make sure good signal integrity, we make sure good power efficiency, and as well as we offer appropriate I/O, assuring good balance between expandability and the cost. Then it is about mechanical. So we take customers' data center specific requirement into considerations, including form factors, serviceabilities, and thermal characteristics. And then after that, it was firmware perspective. We offer firmware, management console software to assure the system will run with customers' specific application with maximum stability and have good compatibility. So all of those for traditional cloud infrastructures, it is about PCB, chassis, firmware, rack and cluster configuration. And that's pretty much about it. However, when we're actually seeing regarding to the new edge cloud applications, we figure out that we need to go further and beyond. So beside all what we did with the traditional cloud infrastructure, we did the following extras. Number one, we actively participated in the telecom interested open foundations. So we participate in the ONFCC programs. We also work with a couple of third-party software stack partners to port certain interesting software with our systems. For example, we're partnering with the Radisys to run the 5G software stack into our edge offerings. And we're demonstrating the first 5G high-resolution video streaming on demand through the 5G edge network. In addition, we're also actively participating in various testing challenges and opportunities. And one good example is the ORAN Plugfest. So basically, we believe since the edge is so new, it will be hard to say port everything to cover all the edge applications. But our idea is simply port few milestone application softwares with our solutions. For our case, video on demand over edge could dramatically benefit customers when adopting our solutions for their edge or 5G new venues. So the second question is that how the new use cases in the edge cloud affect our products and solution enterprises in regarding to the enterprise AI or machine learning and 5G vRAN. So there are a couple of the points actually affect our product solutions. The first one is that there are very, very strong need for extra features which we will have to consider. For example, the FEC or QAT. We'll need to accomplish those considerations via either onboard chip or add-on acceleration card solutions. Secondary, in the 5G world, time synchronization is very important. So in our system, we have to support the precision time protocol or the SYNC-E. And the third one is the further energy consideration. So besides the mainstream x86, we have to support low power consumption platforms such as ARM. And the last one is that system has to be deployed beyond the normal data center environment. So we need to offer solutions with both highly integrated form factor, allowing multiple services running with multiple nodes in one integrated chassis, and solutions which offers more expandability, both from both using the add-on cards or the local storage. So in the enterprise AI and machine learning solutions, those use cases in edge cloud inspire us to support advanced and next generation CPU offering sufficient compute power. Our system needs to offer PCIe design flexibility for more AI and machine learning functions. And also in our design, we actually all have to offer high performance local storage via, for example, E1S, take into consideration from this perspective. So those are the two, those are the points that how we actually, change, how we actually participate into the 5G edge applications, and what all those points affect our product design and solutions. Thank you.
Thank you very much, Stephen. And let's continue with Mike.
Hey, thank you, Marco. Good morning, everyone, or good afternoon, good evening. I really hate going last because the previous three speakers have really gotten all the key points of the challenges in deploying to edge. To give you a little bit of background on Nokia, we became platinum members in OCP back in 2015. Our focus initially then was very much on OpenRack version 2, which we wanted to turn into a telco platform. And so we took that platform and we made several improvements to it. We contributed those back to Open Compute. We contributed back a telco optimized 2-socket server, a 36 OU rack, a seismic zone kit, and we really admired the way that OpenRack was designed and the way that as far as the toolless design, all front panel access, the high efficiency of the way that the platform is designed to optimize processing and compute space. And so about 4 years ago, when we started taking a look at edge compute, it was really very much based on moving toward a virtualized RAN, or a cloud RAN type of architecture. And so we had some very strict requirements in place, right? I mean, Nokia, we've been producing radio access network hardware for 30 years now. So this is really kind of our home field. And so we very much like the OpenRack design. And so we wanted to take and create a platform that very much leveraged the advantages of the OpenRack contribution. And so, key of that was bringing in NEBS, full NEBS compliance, right? So we not only went and looked at the NEBS certification documents, GR63 core and 1089 core. We also went out and surveyed all of our customers, especially our tier 1 customers in North America, and got their edge telco equipment documentation. And we put all those together and really created a superset of requirements. And we use that superset of requirements to really drive the open edge design. And so there's the environmental concerns at the edge that we definitely needed to address. There is also dimensions. We wanted to create a short depth rack or chassis. It's we came out with it's 430 millimeters deep. It's intended to be installed into a 600 millimeter rack, which is a very common rack that's deployed at the edge and the far edge. At the same time, we know that our customers have made a significant investment in the enclosures, especially when you get out to, cell site locations and dense urban regional locations. You have, outdoor cabinets, indoor, outdoor cabinets. You even have pole mount enclosures. So we took the dimensions of a standard baseband unit, that is currently used for doing RAN RAN applications today, And we really designed OpenEdge around that dimension to allow the customer to be able to reuse the investment that they've already put into their enclosures, right? And those investments could be tens to hundreds of thousands of dollars per site that they invest to be able to house that telco equipment. So we didn't want to have them make them go back and revamp that infrastructure, because we were really taking a look at a total cost of ownership when it comes to edge cloud deployments. And then density. We needed to make this as dense as possible, because applications like virtual RAN, especially the VDU, they're very computationally intensive. They do a lot of low-level baseband processing, and the Intel processor, while it's a great processor, it doesn't, it can't really give us the capacity that we need to justify vRAN alone. And so we had to make sure that we had the power in place for accelerator cards. And that's why we put, up to 400 watts for a 1U sled and 700 watts for a 2U sled. So we could take additional accelerators like FPGAs, GPUs, systems on a chip, et cetera, to make sure that we can, deploy the needed compute and acceleration resources to these edge applications. And then as far as, the second question, new use cases for edge cloud, how it's going to affect our production solutions, enterprise, AI, ML, et cetera. There are going to be, right now there's a relatively small number of accelerators that are really focused for edge applications, right, for edge deployments. But going forward, there's going to be a large number of different accelerators that are coming out, multiple flavors of FPGAs, ASICs, eASICs, GPUs, system on a chip, and our different customers are going to be selecting different accelerators to be deployed to the edge. And while these accelerators may ultimately provide similar levels of processing, for specific applications, the interfaces to those are all going to be very different. And so one of the things that we see very important is this acceleration abstraction layer that is part of ORAN Working Group 6. So being able to create a common set of APIs for accelerators to really abstract the details of the accelerator from the application itself, I think is going to be critical going forward to deploying applications that can simply call on an acceleration resource and not necessarily have to be concerned with it being a particular, vendor version and revision of silicon. And so, what we've also done for the edge is we've taken this OpenEdge platform, the 3U chassis, the sleds, the 1U and 2U sleds, and we've contributed these to the Open Compute project. And so we've created this ecosystem around OpenEdge, and I'm very happy that Stephen and WeWin have become part of this ecosystem, because there's a saying that a rising tide lifts all boats. I really do believe the more vendors we have adopting OpenEdge and the more vendors that we have accepting that form factor, the better off we're all going to be as an OCP community. And so Nokia continues to invest in OpenEdge. We continue to make contributions. We're currently in the process of contributing a 2U chassis. We're contributing a switch design that also has precision timing, PTP, included in it with GPS input and double ovenized oscillator for extended holdover times. And we are committed to creating edge-based hardware edge-based hardware platforms. So thank you.
Thank you very much, Mike. And thank you very much all the panelists, like good feedback. I would have
Hey Marco, this is Stephen. I want to actually chime in a little bit. because Mike actually just mentioned he hates to be the last one. So let me take that upload from Mike. I want to actually say over here is that I really want to, and then even though Mike is very humble and saying, everybody already talk about all the points, but I really want to actually shout out that this edge Nokia has been playing such a very important role into this edge forum and community. And then even from our WeWin perspective, Mike actually been a really good mentor and leadership in terms of driving the edge platforms. So I really want to actually give the credit and then give a shout out for Mike as well as Nokia for leading this phenomenal solutions. And I want to actually say, even though Nokia has the very first airframe, and then we're actually contributing to the second platform. And believe it or not, our second platform is even also inspired by Nokia and Mike's inspiration from the previous one. So you're actually going to soon see our second contribution of the edge solutions into the OCP market space. And again, I just want to actually shout out that the huge contribution and the huge phenomenal contribution and from Nokia and Mike. Yeah, so Mike, I'm actually offloading you from the last one. I will become the last one because I love to do that.
Right. Thank you, Stephen. Thank you.
Thank you very much, Stephen. Yeah, so next question would be that, so what is this first use case that your customers has required to support for your edge cloud product and solution? Let's do it one by one.
Shall we go in reverse order this time?
Whatever order. Who wants to go first, please?
Okay, I'll go ahead and take it first. And for us, our first primary application for our edge platform is virtualized RAN, virtualized DU, virtualized CU, and that involves using both fairly dense Intel processors. Up to a 24 core is what we're currently specifying, and the use of accelerators such as Vista Creek and the upcoming Pomona Lake card. So being able to do that layer 1 offload in hardware. In addition to that, I would say other edge applications are starting to come from industrial automation, especially as it's tied into our private RAN or private LTE, private 5G offerings, being able to provide edge computing for industrial IoT types of operations. That's another type of application that's quickly becoming kind of in the forefront of our edge deployments.
Okay, I guess I go next. What we see is initial trials or initial use cases we've been working on is it's not on the Open RAN initiative just yet, but it's on the MDU, the multi-dwelling units, where basically the edge compute platform is residing in a telco closet in multiple buildings and is acting as the edge compute device for some of the application. It will also be able to leverage the SDN framework, meaning fully programmable networking capabilities and open programmable networking capabilities built into this platform. Again, as I mentioned, that the service providers' highest cost is the truck roll to basically go on site and do installations and maintenance and so forth. So the whole idea here is to use this edge platform to scale. So all the way down where at one point the customer can make their own provisioning. If you're familiar with the Telstra networks in Australia, they have a self-provisioning networking infrastructure, which is all based on SDN. So that's why we believe a networking aspect is a key element for that, including the SDN control functions and a typical use case where we've been collaborating on a project. This is for segment routing V6, SRv6. So when basically allows you to do network slicing right at the edge, and on the edge platform. Again, that's why we believe that networking is a critical path for the edge device. Network telemetry is a big element for that, to do analytics. So we building in functions which can leverage the GPU function or FPGA, as many of my previous speakers have said. But so that is also critical to have it at the edge location, to reduce latency, and also to optimize the networking function. So if you're familiar with the Intel Barefoot Tofino architecture, the ASIC, it introduces something called inbound network telemetry, which gives you much more telemetry data than the traditional switch fabric. And collecting this data and doing the analytics at the edge, that's the key part. So this is just the initial one. Where we have big hopes on is, I don't know if you're familiar, but the FCC is allocating funds for something called the Rural Cloud Initiative. We believe that Open RAN will be probably the forerunner for this in the Rural Cloud Initiative. And the main reason is because it's all greenfield, right? It gets quicker when the traditional service providers need to maintain the 4G and 3G infrastructure in parallel to rolling out 5G, for example. So, but this Rural Cloud Initiative for smart farming, intelligent agriculture, and so on, there are a lot of pieces which is a private 5G network, basically, which require platforms which are sizable for that in terms of dimensions. So the open edge platform is a perfect fit in these type of environments, because you don't have a luxury of power, cooling, hot aisle, cold aisle. As a data center, you really have to be able to deploy those platforms in that area. And then, of course, the third one, what we see is the Open RAN portion, right? So but in that element, what we need to consider is the software ecosystem, because these accelerator cards, they need the secret sauce to actually function. And it could be a GPU, could be an FPGA, but we consider it as a white box, but the dependency is still on the ASIC, what's been running on that, because that makes a difference on that. So that's how, that's the initial use cases what we see. Of course, there will be more coming down the pipe. We have discussions with service providers who thinking about it, and there's some potential for 2021, but I think we are just in the beginning on seeing these use cases for the edge compute devices.
So who's the next?
I can go next, since Stephen said he would like to be last. So, yeah. So one of the virtualization on the edge that we are doing is as follow. As I mentioned during the introduction part, we develop end-to-end telco solution, and we do put a lot of focuses on the front haul. So if you take a look at the design today on the front haul architecture, every single RU is connected to a BBU, is a one-to-one correspondent. And as I also share with some of the benchmarking that we learned from working with our customer, a lot of this, radio tower from the RU to the BBU, a lot of time they are somewhat, underutilized. We are looking at some of the utilization may be doing at, around 30% if you look over like a 24 hours period. So we see some opportunity to actually to make this a lot more effective by turning a RU that tied to the antenna, talking to a pooling of the BBU by virtualizing the BBU function. And that is something that we are working on by developing the front haul gateway and also the converged access switch. So, this is like breaking down the traditional CP and ECP, the common public radio interfaces, and then intercept that with the radio over Ethernet, the ROE, and then also support some of the other features required like the low 5 and things like that. The ultimate goal is that allow us to virtualize the BBU from a one-to-one physical device to the RU is now becoming a BBU pooling by virtualizing it. And then looking at technology like DSP, digital signal processor, to process some of these BBU pooling function. And that kind of changed some of the whole topology today, you know, with the RU into the BBU and then into a cell site gateway router before it connect into a central office. Now we have opportunity to support multiple cell tower with the radio head into a pooling of the BBU physically sitting into the central office by bringing some of those, you know, far end going towards the mid hall and the back hall by virtualizing this. And that brings us a couple advantage. One is now we can utilize the resources a lot more effectively. And now we can kind of, you know, sharing the processing and compute power to surface not just one, but multiple cell tower, you know, depends on the traffic pattern. As everybody can expect, a cell tower sitting in Alaska probably has a different utilization than a cell tower sitting in Manhattan, New York, or downtown San Francisco. So we are trying to virtualize the backend BBU pooling by better utilize some of these traffic pattern and then get the most out of that. So that is one of the key examples that we are working on the front hall gateway and the converged access server to allow the virtualization of the BBU on the back end. So I'll stop here for a second.
Thank you. And let's continue then with Steven. So we have like a few minutes left. So let's hope that we could get at least like one question from the audience then. Thank you.
Sure. So let me actually make it short. We have multiple of the POC with the customers, but the two I want to actually point it out is the one which I mentioned earlier before. It's about the 5G video on demand with the high resolution applications. And then with that, we're actually seeing where we're actually virtualizing a lot of the things, for example, like the CUDU in the VRAM, and we're actually virtualizing the EPC and the MEC. And one of the things is that we're actually putting the FEC card into one of our solutions to actually make the whole process actually smooth. Another application I actually want to actually point it out is that we do have a POC actually running is for the edge gaming, surprisingly edge gaming. And then with that, the edge solutions usually we're seeing actually an increasing demand to put in the GPU, and not only one, it's multiple GPU, and those GPU are hot and takes a lot of power. As well as they for the online gaming applications, they also need a lot of the local storage. That's why we're actually having the design to actually, the mitigation is to having the design to be able to fit in multiple GPU in a very, very constrained and short chassis, as just Mike said, as well as the supporting a lot of E1S for local storage. So I want to actually make it quick so that we have more time for the second question.
Thank you very much, for Steven. And thank you very much for the panelists. So is there any like questions from audience?
I recall, Marco, there's about a 30-second delay between what we're doing live and what the audience is seeing.
Okay. Yeah, because I think that we have, if there's no questions, so I'm just thinking because we have pretty much used our 40 minutes now.
Okay. Well, I mean, I would still take a look at, you know, the panelists. Let's continue to monitor the public conversation on the web portal, and you know, we can answer any sort of questions that might come up as they come along.
Yes, this was really good discussion and open communication and good like feedback from different angle on the edge cloud deployment. Thank you very much for all the panelists. Thank you.
Thank you.
Thank you. Have a nice day.
And nice to talk with you. Thank you.
Thank you, everyone.
Bye-bye.